we'll cover the problem first element not smaller than target. So here we'll be given an array of sorted integers, and we're also given a target. We want to find the first element that is not smaller than the target. So 1 is smaller than the target, 3 is not, so we return the index of 3, which would be 1 right here. Now, we know that this array is sorted. That kind of clues us in, like, hey, binary search might be good because we're searching for something and we have a sorted array. In this case, we can solve this problem the way we solved the finding the boundary problem earlier. So here, what we can do is we can actually apply a filter to this array. So the goal is to find not smaller than is equivalent to saying greater than or equal to. So we're saying find the first element that is greater than or equal to 2 in our case here. So what we can do is filter this array and say if it, like, basically we check if each element is greater than or equal to the target. So they've done this here for us. So if we take 1, 3, 3, 5, 8, 8, 10, and the target is 2, we just filter each element. If it is greater than or equal to 2, then we give it true, so that's all of these. And then if it is not greater than or equal to 2, meaning it is smaller than 2, then we get a false value. Because this is a sorted array, we know the condition from the finding the boundary problem must apply, which means that there is one chunk on the left of all falses, and then as soon as we get one true, they're all true. Again, because it's sorted. Then this problem becomes the same question of how do we find the first true, the kind of boundary of the true section, and we've already seen the template for how to do that. So we can go ahead and start coding this. First thing I'll do is grab our last index. You'll notice this will look very similar to that problem that we did earlier. We'll do our left index is going to be 0, our right index is going to be the last index, and we have to have our boundary index. So that's going to be the first element that's not smaller. We can name it like the function, so we can say first not smaller index is going to be, I'm going to default it to -1. Here they're telling us that there must be a satisfying number, so what I default it to doesn't actually matter, but I just prefer to kind of to have this, just personal preference. Okay, then we do our same while loop condition. So long as left is less than or equal to right, we're going to grab our mid index. We'll have our get mid index function, pass in left index and right index. We have our mid value, which is going to be array at mid index. Now here, what we want to do, our condition from before was like find a true. Here we actually have to define what the true is. The true is like element, I'll just write ele, greater than or equal to target. We're trying to find whether or not this is true. If this is true, then we kind of treat it as the true that we saw in our Boolean array before. If it's false, we treat it as a false from the Boolean array. This is the Boolean array I'm referring to, which is also the kind of input to finding the boundary, that problem. Okay, so what I will do is we can say, here, we'll do this. We'll do is greater than or equal to target. That is a bit long. Okay, we can do the other way. We can do is smaller than target is going to be mid-val less than target. And then here we'll just take the negative of that condition. So we'll say if it's not smaller than target, this means that it is greater than or equal to target. Then we can say, all right, this might be the first not smaller index. So we're going to update that value to be the mid index. And remember, there are two cases. One is that we have the right answer, in which case we will not overwrite it in the future. But if this is not the right answer, then we are going to be searching the left chunk of the array, everything to the left of where we currently are. And so we will overwrite the first not smaller index later on if there is a better or more correct answer. So we should be fine making this assignment here. Other than that, we know that we have a true, like we have something that is greater than or equal to, or is not smaller. Therefore, we should see, is there anything earlier than me in the array that also meets the criteria? That would be a better answer. So we want to move our right index inwards and reduce our search space to be the left portion of the array. So we'll say right index equals mid index minus 1. And we can handle our else condition. We've seen this before. We're just going to move our left index to be mid index plus 1. So we're just saying grab the left pointer and move it to the right of where we are right now. So we search everything to the right of us. This is in the case where the current element is smaller than the target. So we know the right answer must be to the right of us. So we can discard everything that includes us and is to the left of us. Now in the end, we can return our first not smaller index. Now all that's left is to write our getMidIndex function. So this is going to take in our left index and our right index. And we're going to compute the mid index using our math. So we'll do left index plus math.floor, right index minus left index divided by 2. And then we return that mid index. That should be all that we need. And you'll notice this looks almost identical to the solution to finding the boundary. The only difference is the Boolean here changes. We actually have to compute it instead of it being already given to us. So we can go ahead and run this. And while that's loading, I just want to emphasize again, this is a really common template for binary search problems. Very, very often we can reduce the problem into, we have an array that consists of some trues at the beginning and then some falses afterwards, or some falses in the beginning and trues afterwards, and find the first occurrence of true or the first occurrence of false, and then you can just use this template. So it's really worth internalizing. Okay, looks like it passed all the tests, so we're good to go. All right, well, that's all for this video, and thank you for watching.